Okay, in lesson one of compensating wage differentials, we're going to look at um, two different labor markets and try to understand why compensating wage differentials are so important. Now, this example that I'm using here actually came up when I attended a meeting of faculty to discuss a $3 million grant the university was applying for. And during the meeting, I learned that they wanted to secure a $3 million grant um, so that we as a university could mentor middle school math teachers into being better math teachers, more effective. Now, during this meeting, I learned that in Guilford County, North Carolina, middle schools math classes were being taught by history teachers. And I was like, why is that? Well, I draw two labor markets, one for math teachers and one for history teachers. Now, because people with quantitative skill, math skill, can get jobs in a variety of fields using mathematics, their market wages in the private sector tend to be higher than people with just maybe history skills, right? So STEM fields, for example, coding, right? Analytics, finance, etc., right? So in the private sector, the two groups are paid different wages. But in a public school system, everybody's kind of paid the same wage, right? So what I did is I drew a line through the two curves that at, like, I don't know, maybe an average salary of the two market wages, drew a line there, and then observe what happened in the supply and demand of history teachers and the supply and demand for math teachers. And it created a surplus of history teachers and a shortage of math teachers. So if you're a school district with all these people wanting to work for you, but in terms of teaching history, not math, you have all these people applying for jobs that want a job in the public school system. And then you have a discipline like math where you have no applicants for the position. What might you do? Well, you might decide to hire new history teachers to teach middle school mathematics, right? That's one way to get around the labor shortage amongst math teachers, right? Now, during the meeting, I raised my hand and I said, well, maybe instead of mentoring history majors, they majored in history for a reason, maybe because they couldn't, they didn't like math or they couldn't do it, right? Nothing wrong with history, nothing wrong with math. But people take history instead of math for probably one primary reason. Maybe they find math to be very difficult. So instead of taking the $3 million and using it to mentor history teachers into being better math teachers, which I don't think is possible, instead of doing that, why not use the $3 million to provide a compensating wage differential? And they're like, what's compensating wage differential? And I'm like, well, maybe you can bump up the math wage a little bit with a bonus to entice people with math skill to consider teaching mathematics in public schools. And that idea was, for the most part, laughed at, right? And people concluded it was crazy because every teacher in high school is doing the same job. They're all teaching. They're all teachers. So everybody doing that job should get paid the same amount, right? So they wanted to continue ignoring market forces. Well, about a year and a half later, I was watching the news one night, and Wake County schools came out with a policy of providing a compensating wage differential for people who could teach math in the public school system. So I felt a little vindicated. Now, I never shared that with anybody on campus. I didn't, say, hey, I told you so. But I just felt a little vindicated. And that's one thing I like about economics, right? We can divorce ourselves from the politics of it, right? And just use economic theory to understand the consequences, bad or good, of certain policies, right? So that's where this model comes from, right? I shared it with a friend of mine from high school. He was getting his master's in education, and I shared with him this model, and it ended up being in his thesis for his master's. And his master's committee just really loved it. And I'm like thinking it's just microeconomics, right? So that's where this model comes from, right? Now we have the math teachers on the left. We have the history teachers on the right. What we need to do is we need to set up Desmos so that, again, math is on the left and history teachers are on the right. To get the Desmos here, I just clicked on this link here, and then I clicked it a second time to have two of them, right? Okay, so let's go ahead and set the demand for math teachers, 92.21 minus 0.25E, right? We'll set the supply of math teachers, 21.7 plus 0.5E, right? So this is the supply of math teachers. That's the demand for math teachers. Now let's do the same thing for history. So we have the demand for history teachers, 73.41 minus 0.25E. And then we have the supply of history teachers, 3 plus 0.5E, right? Okay, now we can use these two models to find the equilibrium quantity. If this were a market system, if hiring teachers was purely market driven, no intervention from the state in terms of licensing or dictating what universities' curriculum was, if it's just purely free market, what would be the equilibrium wage for math teachers and what would be the equilibrium wage for history teachers? And how many people would become math teachers and how many people would become history teachers, right? In a pure market system, right? So the answer to that question is the intersection of demand and supply. So the equilibrium quantity of math teachers is 94.013. And the salary is 68.707. Now, both of these could be in thousands, right? This could be 94,013, and this could be $68,707 per year, right? Okay. Now let's do the same for the math teachers, right? For the math teachers, the quantity demanded is 93.88, roughly equal to that of math teachers, which makes sense, right? But the salary, the market salary for history majors teaching mathematics is only 49,094, right? 940. Well, think of these as in terms of thousands, right? I think it's more realistic. Okay. Now, why is it? Well, outside of public school teaching, there isn't a big market for people with history skills, right? Or there is a massive market for people with quantitative skills, right? So the opportunities outside of the public school system is driving these differentials in the salaries that you'd pay a history teacher versus a math teacher, right? Now, the intercept of the math teacher labor demand implies that schools are willing to pay up to what? This right here is what schools would be willing to pay for that first math teacher, right? Now, they do want to pay that much, right? But they only have to pay 68,707, right? So the school wins, right? Because they'd be willing to pay that much for that first math teacher, but they only have to pay 68,707. So the school wins, right? That right there is the employer surplus. The difference in those two numbers is the employer surplus, right? Now, the intercept of the labor supply curve, 21.7, that implies that there is at least one math teacher out there who has a reservation wage equal to 21.7. $21,000. Right? There's one out there that has a reservation of wage of $21,700, right? $21,700. Who might that be? It might be some retired person, right? Somebody that wants to stay busy. Okay, now what about the reservation wage of the last math teacher hired? Right? The labor supply curve is represents a queue of people, right, who would be willing to supply their labor in public schools teaching mathematics, right? Right? It's the queue from the one having the lowest reservation wage to the one having the highest reservation wage, right? So the reservation wage of that first math teacher, well, that's only $21,700, right? What about the 50th one? Well, the 50th one would be willing to do it for just under $50,000, right? And then what about the last one? The last one is willing to do it for the market wage, right? The market wage is that last math teacher's reservation wage. The last one hired has no employee surplus, no worker surplus, right? So the reservation wage of the last math teacher equals the market wage, $68,707, right? Or $68,707,000 per year, right? Now, what about schools? Schools are willing to pay up to $92,021 for that first worker hired, right? That first teacher hired. They're willing to pay up to around $80,000 for that second one hired, right? What about the last one hired? The last one hired, 68 or 94.013. The last one hired right here, they're willing to pay at most to that person the market wage. So the marginal school hiring that marginal worker has no employer surplus, right? So let's press enter if I know we got them right. So this triangle up here represents the employer surplus, in this case, public schools, right? Or schools in general. And this lower triangle represents the teacher surplus, right? The worker surplus of the teachers, right? And this triangle pointing toward the intersection represents the total surplus. And to calculate that, we have to calculate the height of this triangle is the difference in these two intercepts, right? And then times the width of the triangle, which is the employment level, right? And then we got to divide that by 2. So we got 92.21 minus 21.7 times the employment level, 94.013. Then we got to divide that by 2, right? We got to divide the area of the rectangle by 2 to get the area of a triangle, right? And we get a total surplus of that. Okay, so if I round to 3 decimal places, this 3 means 8 stays at 8, right? Okay, so let's do the same thing for the math teachers, right? Let's do the same thing for the math teachers. So instead of using these equations here, I'm going to use these equations in this graph over here, right? Okay, the intercept of the history teacher labor demand, right? The intercept of the labor demand for history teachers, 73.41, right? That's the most schools are willing to pay the first history teacher hired, right? Now, they're only going to pay history teachers the market wage of 49.940, right? So the school wins, right? They're willing to pay 73,000 $73,410, right? They're willing to pay that much, but they only have to pay this much, right? So the school wins, right? Now, the intercept of the labor supply curve, in this case, is 3. That implies that there is at least one history teacher who has a reservation wage equal to $3,000 per year, right? And I'll make it 3.000, right? There's at least one that has a reservation wage of $3,000,000, right? Now, who might that be? Somebody who loves history, who may be rich and retired or just retired, right? Now, does that history teacher win? Yeah, because they're willing to do it for $3,000 a year, but they're going to get paid $49,940 a year, right? So the difference in these two values is the worker surplus of this first history teacher hired, right? Now, what about the last history teacher hired, right? The 50th history teacher hired would be willing to do the job for just under $30,000, right? The schools would be willing to pay that history teacher just over 60, right? So the maximum they're willing to spend is 60, just over 60, right? But what about the last one hired? Well, the most the schools will be willing to pay the last teacher hired is the market wage. So schools have zero employer surplus or firm surplus when they hire that last worker. What about the worker, that last worker, him or herself, right? Well, that last worker hired, their reservation wage is this market wage. So the last worker hired, last history teacher hired, has zero worker surplus, right? Because they're being paid the reservation wage, right? So the reservation wage of the last teacher hired is $49,940,000 per year. Schools are willing to pay the last history teacher hired no more than $49,940, right? 49.940, right? And we got to calculate the total surplus, right? This again is the school surplus, and this here is the worker surplus, right? This is the worker surplus in school, and the school surplus, the employer surplus up here, right? The total surplus is from this intercept down to this intercept, and then out to the employment level, right? So what we have to do here is we have to subtract the intercepts. Then we're going to multiply that difference by the employment level, 93,880, right? Put a decimal place there. And we got to divide that by 2 because we don't want the area of a rectangle. We want the area of a triangle, right? So the total surplus of in the history teacher market is, and we'll round to 3 decimal places, is $3,305, right? 0.045, right? So now this is actually $3.3 million because we have 1,000, right? We have 1,000, right? So this is actually $3.3 million, $3.3 million. And this is $3.3 million, right? Roughly. Okay, because again, it's 1,000. Okay, now in a market system, right? Theoretically, there is no surplus of math teachers and there is no shortage of math teachers. Same thing with history teachers, right? Because market forces, the market is allowed to work here, right? Without government interference. So theoretically, the number of people who schools want to hire to teach math is 94,013. The number of people who are willing to do that work is the same, 94,013. The same goes for history teachers, right? 93.88 thousand schools want to hire 93.88 thousand, and 93.88 thousand want to work at that wage rate, right? So the unemployment rate of both is 0%. And then the total surplus is just a sum, right? It's this triangle here, the area of this triangle here, plus the area of this triangle here, right? So all we have to do there is just add this labor market surplus, this math teacher total surplus. We got to add that to the history teacher markets total surplus. And we get $6,619.473, right? Whoops. I'll just copy it and paste it over here. Right, so we just add this and that, right? We add those two together and we get the total surplus in both markets, right? Now, suppose members of school boards all over the nation decide that it is unfair to pay different salaries to teachers based on the subjects they teach. In other words, they're going to ignore the market signals, right? What are there any consequences of that? I mean, there are good consequences because, you know, if everybody in the school is paid the same wage, they'll kind of feel like they're, you know, contributing the greater good of educating tomorrow's leaders, right? But at the same time, a math teacher who has friends in the private sector making a lot more money per year feels like they're not being paid their value. And for that reason, they may leave teaching to get a more lucrative paying job in the private market, right? In the private sector, outside of school systems, right? So I think there's some good consequences of doing this. And so I think the judgment is, does the good that this policy does that outweigh the bad that it does, right? And we got to look at the good consequences and the bad consequences, right? So suppose the school board sets this uniform teacher salary at the market average. So we're going to average the two market wages, right? I don't think I need that anymore. I don't think that I need that anymore. So what's the average of the market wages? Let's go back up here. So we're going to have the average, right? So the math market wage is 68,707. And the history wage is 49,940, right? Put our decimal places in there. And we get an average salary of $59.3235 right? Okay, so now every teacher is going to get paid this average, right? $59.324,000. Now, when I enter that number in, notice what happens here. I get this red horizontal line through the math teacher market, and through the history teacher labor market, right? Now, this red line is below the market wage, and this red line is above the market wage. So over here on the left, this is a binding price ceiling on math teacher salaries. Over here, this is a binding price floor on history teacher salaries, right? At that salary, blank math teachers choose a teaching career. So to figure that out, right, what I'm going to do is I'm going to set y equal to this, right? Yeah, so, and then I'm going to change the color to red, right? I'm going to put it over here too. Okay. So I have the binding price floor in the history teacher market, and I have the binding price ceiling in the math teacher market, right? Now, how many math teachers are going to choose a teaching career? Well, that is the point where this binding price ceiling crosses over labor supply, right? Only 75.247 math teachers will decide to teach, right? Why? Because the last of these guys, the last of these people has a reservation wage equal to the uniform salary set by school districts, right? So 75.247, if this is in thousands, and you have 75,247 math teachers choosing a math career, right? Now, because schools are paying an annual salary that is blank thousand below the market salary, right? That's because schools are paying an annual salary that is substantially less than the market wage, right? So all these teachers here, the teachers that populate this labor supply curve up to here, they all think they're being underpaid, right? They believe their value is higher. So they feel maybe some animosity toward the policy, right? Wait a minute, my friends are making $68,000 a year in the private sector, almost $69,000 a year. And you only value me at $59,000? Well, I'm going to go work in the private sector, right? And earn $68,707, right? Okay, so we have to calculate the difference, right, between the two. So we have 68,000 $68,707,000 minus this 59,000, right? 59.324. So $99.383 is the difference between what that teacher will make under the uniform salary model and what they'd make in the private sector. And so that's why you see math teachers leaving teaching, right? Because they can make a lot of money in the private sector, right? Not all of them, but some of them will, right? And at the same time, schools would like to hire how many math teachers? Well, at this artificially low salary, schools would love to hire 131.546 math teachers, right? Because they're a bargain, right? And maybe because parents want their kids to learn math, right? Because they know that, there are lucrative careers in the quantitative fields, analytics, data science, statistics, finance, right? So maybe they want to offer more math classes, and they would like to, right? Okay. Now, at the uniform salary, how many history teachers choose a teaching career, right? So now in the history market, this uniform salary is doing what? Well, again, it's a binding price floor for the salaries of history teachers, right? And so the intersection of it and demand gives the number of people who would like to teach history at schools. That's 112.647. Okay. They want to teach at schools because schools are paying a salary that exceeds the market annual salary by how much? Right. So this uniform salary of the public school system, 59.324, is how much above the market salary? Well, the market salary, if you remember, was 49.94, right? Okay, so the difference is 9.384, right? So they don't want to work in the private sector. They want to work for a public school, right? Making 9,000 more per year, right? Than what they would in the private sector. Now, at the same time, because the cost of hiring history teachers has gone up, schools scale back or like to scale back their history departments by hiring just blank history teachers, right? So they want to hire just what? They want to hire just 56.346, right? At this uniform salary. Okay. So what do we have here? At the uniform salary, we have a what? We have, let me pull this down here. We have in the math market, we have what? Schools want to hire 131.546 mathematicians, but only 75.247 want to work at that uniform salary because they can make more in the private sector, right? So what's that difference there? That difference is the shortage, right? 131.546 minus the 75.247. Okay, so this is what is demanded and this is what's supplied. So there's a shortage, right, of 56.299. Okay, we'll go with 56.299. Okay. I think I had it rounded to 2 decimal places. Oh, that says 3. Okay. We'll see how that goes. Surplus of 56.296 math teachers. Oops. Yeah, I had to change that to shortage, right? Because this is what's being demanded and that's what's being supplied. So there's a shortage, right? So I just picked the wrong one. All right, what about history teachers, right? Let's go to history teachers. We'll go to the history teacher model. So in this one, we have 112.647 people who want to be history teachers. 112, sorry, 112. We have 112.647 people who want to be history teachers, but schools only want to hire 56.346. Right? They only want to hire that many, right? 56.346. They would like to hire this, or this is how many people want a job teaching history. And this is the number of people who the schools want to hire, right? So there's a surplus, right? A surplus. So which one is it? 56.301. A surplus. Let's go with the 304 here. And that's the right one. A little bit of round off error here. Okay, cool. So we got a shortage of math teachers and a surplus of history teachers, right? So if you're a school district and you have all these math classes, middle school math classes, and you haven't been able to hire anybody to teach those math classes, you have a bunch of these people who have applied to be history teachers, but you already have enough history teachers, right? What might you do? Well, you might hire the history teachers, the new history teachers, the experienced history teachers have seniority. They're going to teach the advanced history courses in high school, right? So you get these new teachers, these history teachers, and you ask them to teach math classes. And that was going on in Guilford County when I went to this meeting back 2005 or 6. I forget what year it was. Okay. So the school asks the new history teachers, right? Because they have no seniority. They haven't been, I mean, if they don't do this, they don't have a job, right? So you can hire them. You know, they apply for a history job, and then you can say, well, we can hire you, but you have to teach math for a couple of years, right? So what is that person going to do? All right, I'll do it, right? In the hopes that they eventually get to teach history, right? And they're teaching the math classes, right? Not AP calculus, not algebra 2, right? They're going to teach the middle school math, right? The remedial math, the easy math, right? So students in middle school who struggle quantitatively, instead of getting a mathematician to teach them mathematics, they're getting somebody who chose purposely not to get a degree in mathematics. They're learning math from somebody who chose not to major in math to teach them math, right? So I think that's bad for the kids. The kids in that situation, right? Now, after decades of math teacher shortages caused by uniform teaching and salary policy, school districts desperate to end this problem propose a compensating wage differential, right? Now, the wage differential isn't going to be the difference between the wage that is paid to people in the private sector doing quantitative jobs and the market wage of people, market wage of people with history skills, right, or history degrees. It's not going to be that differential, right? It's going to be the difference between the market wage, the wage that you can earn in the market, less this uniform salary, right? So the 59.323. So 68.707 minus the 59.323 is going to be that compensated wage differential, right? Which we calculated right there, right? Now, when math teachers are paid this differential, right? You adding that to the uniform salary puts their total compensation at a market rate, right? And what does that do? It results in this outcome here, right? This red line here is no longer binding. It's no longer a binding price ceiling for math salaries, right? It's basically allowing the equilibrium to work, right? So math teachers' total compensation now is the market wage of 68.707, right? And the number of mathematicians that are going to work under that salary, right, are willing to teach math is 94.013, which equals the number the schools want to hire, right? 94.013. So there's no unemployment in the math teacher market. So schools are going to demand this many math teachers. And the number of math teachers supplied is going to equal that number, right? So there's not going to be any unemployment in the math labor market, math teacher labor market, right? Now, that's not the case in the history teacher market, right? In the history teacher market, people are still being paid this uniform salary, right? But they're not getting the bonus. They're not getting this compensating wage differential, right? Now, because everybody that graduates high school, right, or college with a history degree and maybe a credential to teach history in a public school, they know that schools are paying 59,324, right? They know that all schools are paying that one salary, right? And they know also in the market they can only get $49,940 a year, right? So this uniform salary, this binding wage floor for history math salaries encourages people to get that degree to teach history in the high schools, right? And 112.647 get those credentials, but the schools are only hiring 56.346. Now, before the compensating wage differential, right, this excess number of history teachers, they got hired to teach math in middle school. Well, now with the compensated wage differential, there's no shortage in math teachers. So now what this binding price floor on math teacher salaries does is it creates unemployment. And the difference between these two numbers, right? The difference between these numbers is the number of people who are unemployed who would like to teach history in high schools, right? So this leads to unemployment.